Hello students, and welcome to our second video here for calculus. In our first video we introduced this thing called the exponential function y equals e to the x, where e, Euler's number, is approximately equal to 2.7, and the derivative of that function y equals e to the x is also the same function, e to the x. We have not so long ago been looking at transformations of graphs, and in this video we're going to look at some more transformations specifically relating to that exponential function y equals e to the power of x. So let's jump into that and see how it goes. Sketch and write the equation of these functions if I have a horizontal asymptote at y equals 4. I want the standard exponential function, so instead of y equals e to the power of x with a horizontal asymptote of y equals 0, now it's y equals 4. So our function will be y equals e to the x plus 4. This function has been translated up 4 units, so we just add 4 to the function. Yeah. The dotted line here represents the original function y equals e to the x. You can see the y-intercept is at 1, e to the power of 0 equals 1. Right. I have a horizontal asymptote being the x-axis, and then it climbs quite quickly to the right. If we take this graph here and slide it up 4 units, my y-intercept goes from 1 to 5, my horizontal asymptote goes from 0 to 4, right. And other than that, it continues to climb here on the right. So that there, the red line, represents this function y equals e to the power of x plus 4. Next up, I want to translate this function 2 units to the right. Okay, so moving or translating a function left and right means we replace x with x minus 2 in this instance. So I replace x with x minus 2 and end up with this function here, y equals e to the power of x minus 2. Right, and that will shuffle the function, will translate the function 2 units to the right. Again, the dotted line represents that basic function, y equals e to the x, and the red line represents the transformed, in this case translated, function y equals e to the power of x, e to the power of x minus 2. Now, that would mean that my original function has a y-intercept of 1. That means this point here, 2, 1, right? The point 2, 1 will lie on that red line. The y-intercept of the red line now, well, I would have to substitute x equals 0 into my function. I get e to the power of negative 2, or 1 over e squared. Okay, and that's where that y-intercept is there. Next up, I want to reflect this in the y-axis. Okay. So to reflect a function about the y-axis, what I do is I replace x with a negative x. So instead of e to the x, I have e to the negative x. And its graph will look like this. Okay, the y-intercept of course stays the same, but now I have exponential decay instead of exponential growth. The horizontal asymptote hasn't moved. Okay, but I approach 0 on the right instead of on the left. And I think this is the last one. I want to reflect the function in the x-axis, and what that really means is I make all of my function the opposite sign. Okay, so I'm going to say that y equals the negative of the function. Right, I multiply my entire function by negative 1. I get negative e to the x. Be careful, that is not, of course, negative 2.718 to the power of x. That's a very problematic function. You know, we do the exponential first, so it's the negative of e to the power of x. That's my original function, represented by the dotted line, reflected in the x-axis, so that it goes down instead of up. My horizontal asymptote is still the y-axis. The x-axis. My y-intercept now becomes negative 1 instead of 1. Right, I take all of those values from my original function and change their sign. And of course, the range of the exponential function is greater than or equal to 0. So the range of this function here will be less than or equal to 0. Oh, sorry, strictly less than. The range of my original function is strictly greater than. It can't be equal to 0. Bit of a mistake there. Anyway, that's it. Transformations, the same as all those other transformations we've done, just a bit of a refresher, I suppose. Next up, we'll be looking at the differentiation of exponential functions. If you've got any questions about today's video, make sure you jot them down so you don't forget and ask me in class. I'll see you there.